Let's go ahead and take a look at 4 different problems here involving the inverse trigonometric functions. The first problem asks us to simplify the arc cosine of square root of 2 over 2. So what we need to do is we need to think about, first, is this a proper value to get plugged in? Are we alright plugging in a number like square root of 2 over 2? Well, the numbers that can only be plugged in have to be between -1 and 1. Well, square root of 2 over 2, let's just go ahead and check that. Let's close this out here. Let's just grab a calculator. And so if we take the square root of 2, let's find my square root key, and then we divide that by 2, we end up with a number that is in this range. So we're good. So the input is okay. Now the output is to be an angle. The question that's asked here, this right here, another way of stating this in words is, what angle has a cosine value of square root of 2 over 2? Now remember, the only angles that can come out here for cosine, because of the range of the arc cosine function, the only angles that can come out are between 0 and pi. So we need an angle, and let's take a look at this. We need an angle that's between here and here that has a cosine value that's square root of 2 over 2. So we take a look at our unit circle, and we know that the only angle that has that over that range is pi over 4. If you take pi over 4, its cosine value, the cosine value of pi over 4 is square root of 2 over 2. So the answer for this is pi over 4. Okay, let's go ahead and take a look at this guy over here. So for problem number 2, it asks us to find the inverse cotangent of negative square root of 3 over 3. Another way of saying that, so what it's asking for is find an angle whose cotangent value is negative square root of 3 over 3. Another way of phrasing the same question, instead of asking this, is to ask this. Find an angle whose, when I said, okay, so find an angle whose cotangent, we could say find an angle whose tangent value is the reciprocal of this. So that would be negative 3 over the square root of 3, which when we rationalize the denominator, we would get negative 3 square roots of 3 over 3, which is just negative square root of 3. Now we're not looking at the arc tangent, we're looking at the arc cotangent. And arc cotangent, the outputs are between 0 and pi. The inputs can be any real number. Okay? So what we're asking for is from 0 to pi, where is the tangent at negative square root of 3? So let's go ahead and take a look at that picture. So from 0 to pi, we want an angle whose tangent value is negative. Well, so it's got to be negative, so we're looking in quadrant 2. And we want square root of 3, so that's the more steep of these guys. And so that's going to be at 2 pi over 3. So this will be 2 pi over 3. Now the one thing we should do is we should check these values out here on our calculator as well. I'm going to pull up the TI calculator because that's what you're most used to seeing. It gets finicky with the recording program going, so we'll see how long this thing lasts. But let's take a look at this first one right here. We want the arc cosine of square root of 2 over 2. So let's go to our mode. We'll leave it in radians because my answer was in radians. And so I'm going to go arc cosine of square root of 2 divided by 2. And I'm going to get that value, and then I'm going to make sure that that matches my pi over 4 value, and it does. So the angles are the same. So what I did here was correct. Now let's take a look at this guy over here. There is no arc cotangent button in my calculator. So here's where I've got to be careful. I can take the arc tangent value if I want, but what it's going to give me is a value out over here. Okay? So, because if I do arc tangents of negative square root of 3, arc tangent is only on these two quadrants. It doesn't come up over here. So it's going to give me the guy down here. What I have to add to that would be pi to get myself, because what it's giving me, guys, is it's giving me this angle down here. I'd have to add pi to get back up to the angle that I really want up there. Okay? And so now, so I get this angle out here, and let's just check 2 pi over 3 gives me that same angle. Now another way to check this is to take the cotangent value of this and see if we get this guy inside here. So we could take the cotangent, which is 1 divided by the tangent value of 2 pi over 3. We get negative 0.577, and hopefully that's the same as negative square root of 3 over 3, which it is. So my first two problems check out. Let's do the last two problems here. Now my recommendation is when you have composition of a function and its inverse is that you draw out the picture. Drawing out a picture is always a good idea, and I've been talking about this all semester. So to do that, let's take a look at just the inside piece here first. This says, this inside piece, arc cosine of 5 over 13. This is an angle. Let's call that angle something. Let's just call it theta. So there's an angle out there whose cosine value is 5 over 13. That's what this says. There's an angle. There's an angle theta whose cosine value is 5 over 13. So let's go ahead and draw that picture out. So what that would look like, now remember my angle, because this arc cosine is only, this guy right here is only between 0 and pi. So I got to pick quadrants 1 or 2. So where is cosine positive? In quadrant 1. So let's go ahead and draw that guy out. Now I don't know what my angle is. Let's just call it theta, right? But we do know the cosine is 5 over 13. So this is my triangle. Okay, and of course this side's 12, but we don't need it. Now we're going to use this information to answer the full question. The full question is, this arc cosine of 5 over 13, this is an angle. We called it theta. So the question is, what is the cosine of this guy? Well, this guy is theta. So here's what I'm going to do. I'll write it all out for you. The cosine of the arc cosine of 5 over 13, that is the same as the cosine of theta, because theta is equal to this. So the real question is, what is the cosine of this angle? And the answer is 5 over 13. So you might say, oh, that's easy. Look, I'm just going to cancel this with this, and I'm going to get my answer. Wrong. Okay? Totally wrong. So even though it works in this one case, we can't generalize this. Okay? So yeah, I know students, you guys like to look for patterns, and you're going to look at, oh, I just cancel this with this, and there's my pattern. Well, watch what happens. So let's take this example right here, which was chosen, obviously very wisely by myself, to counter this example right here. So there's some thought that goes into this, right? Okay, so now look. Let's do the same guy out here. So let's call this guy, let's call it something else. Let's call it, I don't know, angle M. Who cares? It's a variable, right? So we know this inside piece right here. Let's read this inside piece. This inside piece right here, just this, the sine of 5 pi over 6. We're going to let that equal angle M, whatever M is, right? So we don't know what the angle is. Now, in this situation right here, okay, the sine of 5 pi over 6, we can find M. Let's draw a picture of that out. Okay, so to draw a picture of that out, okay, here's 5 pi over 6 right down here. Okay, and what you're going to see is that we can't just cancel this with this. It doesn't work like that. Okay. So what angle, or excuse me, this is not an angle. I said that wrong in the beginning. This is a value. Okay. We can still call it M, but it's a value. When I said angle, I said that wrong. So this guy in here is not an angle. This guy in here is a real number. We input an angle into the sine function, we get out a real number. Well, what is the sine at 5 pi over 6? Well, we know from the unit circle that the sine value at 5 pi over 6 is 1/2. So that means that this is 1 over 2. Okay, or 1/2 over, and then 1/2, and then this guy would be 1. Now, watch what happens here, though. When we replace this piece with 1/2, because they're equal, we end up with, the full thing looks like this. The inverse sine, or the arc sine, of the sine of 5 pi over 6, that's equal to the arc sine of 1/2. Now, what is the arc sine of 1/2? Now here's where we have to be careful. Arc sine is only defined in these two quadrants. Quadrants 1 and 4. For its range. Okay? Its output is only defined over here. We only take acceptable values in here. Okay, not the domain. The range is only defined on this piece. So, this question asks us, what angle, because we're using this, so this has got to output an angle. So what angle has a sine value of 1/2? Well, it's got to be on this portion of the circle. So that angle, guys, is pi over 6. So this thing is equal to pi over 6. If you would just cancel these, you'd have got an answer of 5 pi over 6, which is completely incorrect. So be careful, draw your pictures out, work the inside first, get an answer out, plug that in here, and then work out a whole new problem for it. So you just work it step by step.